Okay, hello. Uh, Welcome to the second episode of the tutorial series for your first NASP mission, Apollo 7. So I was thinking, how do I want to handle this? And I was thinking, do I want to explain all these systems now, or, or what? And so I thought about it, and since the startup is having you interact with every system, I thought that that might not be the best time to explain it. It's for new people going to be a little bit of a time crunch, and I thought it just made more sense if we could isolate those systems as they're applied in space. Uh, so I will be going through the systems while we're starting up. I'll show you where the switches are. I will give a one sentence, two sentence summary of the system we're interacting with, but I won't get into the nitty gritty details until it comes up in the checklist for Apollo 7 in the actual mission. So I hope that's okay with you all. I hope we can all sort of agree on that, and let's take it down. So we are 3 hours, 35 minutes, and 50 seconds mark to liftoff. The next thing we have to do is our secondary glycol loop check. So this is a backup to the primary glycol loop. It's responsible for cooling off the spacecraft. Very simple explanation. So the valves for the environmental control system, here's the coolant attenuation panel. Up here we have a few more valves. Here's the secondary glycol to radiators. Flip over to secondary, switch on AC1 pump, and switch on down to AC2 and verify that the glycol discharge pressure is still holding. Good. Set the secondary coolant loop pump off. You can see it slowly spin down now. Switch back to primary, and you can bypass the secondary glycol to radiators. We're now going to go through the primary loop activation. This loop is a little more sophisticated, but it's essentially the same thing. We're on primary. We're going to verify that the glycol loop holds with pump 2. Set it to off. We could see it slowly spin down, and then go to pump 1. It was not under its own power earlier, but now that we've activated the pump, it is now under its own power, and so if we take the pumps off, it will not hold the pressure anymore. Radiator flow controller. The radiators, they just cool things off. They work with space. More on that later, because they can also take in heat, but they're not supposed to. But they can take in heat if you're not careful. So we'll talk about the radiators more extensively. But we're going to turn it on, switch to the secondary system, see if it works, switch back to auto. It's good, and turn it off. Now we're going to open direct O2 to 0.4 plus or minus 0.11 pounds per hour. So that should be about right here. The checklist tells you to open it a little bit past halfway. However, I find that that's actually still a little too far. First initial setting is probably enough. Ooh, still might be too high. We might have to full close. See, now it's not enough. All right, so let's take it just past halfway, like that. It'll go full scale, and then let's take it down and see what it'll come up with then. While that's happening, let's do our caution and warning, standby inverter checkout. So first things first, we'll need to activate the caution and warning. The inverters will take DC energy and convert them into AC energy. Well, invert them into AC energy. The conversion would be from AC to DC. So essentially we take power from here, power it to here, and we get AC instead of DC. It's good stuff. Yep, so that's good. Yeah, so essentially what we did there is we turned the sensors for AC2 off. We powered off inverter 2, powered on inverter 3. Well, we didn't power off inverter 2. So the power for the inverter is received by the main buses. Input, main bus A, main bus B, and 3 can go on either one. These tie it to the bus. So we just took off the tie from 2 and tied 3 to the bus and turned back on the sensor with the reset switch. And we verify we're holding AC volts. That's good. Turn the sensor off. Untie inverter 3. Tie inverter 2. Reset the sensing equipment. We get the master alarm. Light's not on though because we do have stable voltage. And unpower inverter 3. Verify stable voltage on all phases for all buses. So each bus has 3 phases, 3-phase AC current. And now back to acknowledge. Verify the radiators are open. They show gray, gray, gray. Verify that these circuit breakers are pulled. And there's our fuel cell check. The float bags, this one's easy. Take these switches to off, plug in the circuit breakers, take them to vent, wait a few seconds, open the circuit breakers. Very simple. Float bags will keep us upright after landing. The suit attenuation panel, the suit exchange attenuation panel, and the coolant attenuation panel, they are all automatically tended to prior to the mission by the ground crew, so nothing we can really do there. We're going to check down here, and everything here looks pretty good as well, so let's take over to the LEM tunnel vent and set it to the differential pressure. Essentially describing the pressure difference between the LM and the CM. We're not docked, so needle should be pegged on high. Rendezvous transponder. We're going to make sure that the heater is working. Switch it down. Mission timer. Reset. Here, the interaction is backwards. Left click will flip it down. Right click will flip it up. It's a little backwards, a little glitch, but it's okay. Start. And stop. Stop. Reset. And then let's do that test for the transponder. Test 5 alpha. Verify the voltage is correct. It should be 1.1 to 1.9, so between 1 and 2 essentially, and that's good. Let's test 2 Bravo. 5 Bravo should show 0, that's good. We can turn these heaters on. Make sure this is in operate. It's a spring-loaded switch, so we're good. Come back over here, open the lighting coax tunnel rendezvous spotlight main B circuit breaker. Everything else should be good down here. We can close the battery vent. So the batteries over time accumulate hydrogen gas, so we're going to need to vent that so that we don't explode. But in space is not an issue. We can close that then. And then vent the waste. The waste stowage is essentially, the solid waste goes in this bucket and it's saved, and we vent that so that the smell is not terrible. We will save the solid waste for health analysis after the flight. Altitude setting as desired. Let's leave it. That was referring to panel 13, the orbit rate display, Earth and lunar. Repress package. This is used for repressurizing. Set that to on. Verify all the autopilot controls for the RCS are set to off. Well, not only autopilot, but also SCS. But brief description, we'll talk more about these things later. We can close the service propulsion system, pitch and yaw, battery A actuation ties. Open the docking probe circuit breakers. We don't have a docking probe on this craft, so they're dummy breakers. And we can get our stuff pretty much online for attitude. So let's power up both FDAI. Let's power up the GDC and ECA electronics. Signal conditioners. And BMAGs to warm up. They already are. Let's take a look at that O2. O2 situation, still a little high. Let's crank it down to this position. As you remember, should be 0.4 to 0.51. Set the translation control power on. The rotational control normal. AC/DC cross tie. SCS and free. BMAGs on rate 2. These should be guarded. GDC over here, the attitude set for the GDC should read as so. These motors should be off. LM CSM, auto, covered. Set this to GPI. Make sure it goes to 0. And we'll stop, center, reset the event timer. Docking probe over here should be off, and off, so center, or guard, center. Here we'll go uplink telemetry to accept for the command module and block for the instrument unit. Let's switch to propellant quantity for the RCS indication. And let's open the secondary RCS fuel pressurizer. Verify everything. Verify the helium tank temperature as well, which A is hot and the rest are not, most likely due to the direction of the sun here. Back to propellant quantity. Verify everything is 100%. Good. Open the command module RCS propellant isolation valves in case we have an abort. That would be nice. And just verify pre-pressurizing pressure and temperatures. and that's good. Transfer command of RCS to service module, and make sure that it is off. The abort system should be full auto. Up at the top, this valve here should be closed. This valve here should be closed, and this should show about 800 psi. All right, right-hand side. It's working through the checklist right now. A lot of stuff is preset. LM power can be open since we're not bringing the LEM. Ensure fuel cell heaters are on, radiators are normal. Purge switches are center or off. Reacts are open and gray. All ties on main B should be off right now. Ensure that the fuel cells are at their pre-operating conditions. These should be low scale green. 2 and 3 should be off, and fuel cell 2 should be low scale green. Ensure that the DC plant shows nominal, so 1 and 3 have no draw, so they should show about 0 amps. It won't show exactly 0 due to background noise from the gauge having to be powered, but it's just a little gauge physics. We'll talk more about that later. Fuel cell 2 should be producing a small bit. Main bus A and B should have stabilized voltages in amps. And the batteries should all say around 37 volts. The pyro batteries should say 36 or around 38. Back to main A. It's verifying the inverter setup here, which we should have correct because we did do the inverter test earlier. Verify stable buses on all 3 phases, and we're good. SPS stat checks. We're verifying this gauge up here. Temperature is good. Helium pressure is good. Fuel pressure and oxidizer pressure are good. Oxidizer unbalance is 0. Oxidizer flow is max. Should be increase primary, and the pug mode should be off. We'll have not a full tank of fuel since this is Apollo 7, an Earth orbit only mission. We can also verify the engine nitrogen pressures if we wanted to, and they're good. And now, uplink telemetry, command reset, then off. Barber pull on the tape. Just verifying the radio positions. You all do have checklists, of course, available to you, so things that the checklist are skipping, I will not cover for the launch at least. Tape recorder, let's rewind it, verify tape motion, then off. BCM bitrate should be high. Mission timer. Reset, stop, then start. Verify counting up, verify ACK. Cryo pressure verifications are looking good. Let's take a look at that surge tank. That surge tank looks good. It's about the same as the repress package, so that's fantastic. Quantities are 100. Good. Set our heaters and fans to auto. Environmental control system checks. Verify the gauges. Makes sense. Verify the temperature and the pressures here. Makes sense. And the millimeters of mercury here. Makes sense. Verify potable and wastewater quantities. And they're good. They make sense. Potable should be around 80. Waste should be around 20 to 50. All right, suit heat exchanger on for 20. Skip a little time. Then off. Reset on the secondary coolant loop for 1 minute. Then off. Make sure the pump is off. Now we'll set up the primary glycol evaporator system. So it should be increase for 58 seconds. And down for 9. Good. All right, let's activate those comms. Get that primary transponder power amplifier high. After 90 seconds, we should show power amplification. And that's great. VHF-B on duplex. Which panel was the CDR? All right. Commander. Seat power. Command module pilot. Lunar module pilot. We'll do comms check, and it's good. And then we'll come down here, we'll set some volumes. Okay, now we're ready for prime crew ingress very shortly. Power off caution and warning, and pull the circuit breakers. Ground crew will now egress, and the primary crew will ingress. We can skip time while that's happening. Okay, everyone's where they should be now. We can take off the power amplifier and the transponder and power up the caution and warning system. boost. Perform potable water chlorination. That is not simulated yet. We can come over here to the food prep station, which requires the two-dimensional cockpit. Open the cold and hot valves real quick. Get Directo to open to 0.6 to 0.8. So open it by one position. That's good. And we'll get the suit compressor on, which should bring that light out. Good. Suit compressor. Cabin differential pressure is good. O2 flow is remaining. We can get that rendezvous transponder off now. And get the S-band back online. PCM bitrate to low will allow you to skip to up to times 100, otherwise you can't skip past times 10. So the CDR will ingress left-hand couch. We can hear the suit compressor powering up. Let's get the cabin fans on. LMP ingress right couch. Verify a couple switch positions. Oxidizer flow now normal. Go to Omni Bravo. We already are. CMP ingress center couch. Good. Suits H2O accumulator. Auto 1. Uplink telemetry command, normal. Command module uplink telemetry, lock. Panel 10, is it this one? Nope, other side. Nope, it's the middle. Here we go, 10, back up. PACCOM off. Okay, the emergency detection system. This is responsible for detecting emergencies that may happen during the ascent, which would trigger the auto abort system if flipped to auto. Okay, uplink telemetry command off. Panel 9, S-band off. That's the other side. S-band off. Intercom off. VHF off. PADCOM off. Sorry, PADCOM off is on panel 6, which is over here. PADCOM off. There we go. Alright, and now we got lots of time to skip. So we can come out here, just start skipping time. You can see we're tanking now. Because we have our PCM bitrate set to low, we can time skip to X100. And we're just going to take her all the way down to 1 hour and 40 minutes. And then I also realized that my mouse is not showing for whatever reason, even though I have game capture set to capture cursor. Yeah, interesting. I cannot get the cursor to display. Oh well, I guess. You'll see what switches I'm flipping still, obviously, but it'll make it a little more difficult, but I guess I could window capture. Yeah, let's try window capture and see if that'll work. Properties, capture cursor, good. We'll just hope that's capturing now. Should also be capturing sound good. Alright. Cabin closeout now. We can get the door to close. A little bit tricky here. If you can't get it, just hit execute on the checklist for a split second. There we go. She's closed. Gearbox select to unlatch. There we go. Actuator select U. Can't interact with it still. There we go. And we can get those cabin fans off. And let's wait around for EDS test complete. EDS test complete. Get everything back on here. PACOM's back on here. EDS power off. Auto off. Make sure the launch vehicle indicator here is set to Laplace. Skip a little more time. And let's get our gyro powered up, so caution and warning to normal. Turn off the FDAI. Get B-mags on. FTAI power to both. Caution and warning to acknowledge. We're now going to do a GDC align. Select ball 1. Attitude set. And GDC. Verify 152, 90, and 0. GDC align. Rate should be null. 158. Down to 81. Yaw to 355. Switch to ball 2. Ensure that it comes up properly. Good. And let's do a GDC align. That'll motion. Make sure it goes on all 3 axes. And back to 152, 90, and 0. Switch back to ball 1. Make sure it comes up properly. And GDC align. Make sure all 3 axes move. No motion. Push release. Alright. We can now get our fuel cells tied. So let's tie fuel cell 1 to main bus A. We can see fuel cell 1 has come online. It's producing. Fuel cell 3 is still offline. Fuel cell 2, make sure it's tied to main A. We should have gray, gray, barber pull. And now we'll have barber pull, gray, gray. So let's get fuel cell 2 tied to main B. And let's get fuel cell 3 online on main B. And there we go. Let's get our main bat ties on. Verify TVC power. Start pitch and yaw motors. Do a trim check. Minus, plus, 0, minus, plus, 0. Perform manual thrust vector control check. You can do that with 8, 2, 1, and 3. Looks good. Set the SCS thrust vector control, pitch and yaw to auto. Start motor 2 for pitch and yaw. Rotate abort handle clockwise. That's very important. To the right, or clockwise, is a manual takeover. To the left is a mission abort. Very important you do not screw that up. Minus, plus, 0, minus, plus, 0. Verify manual thrust vector control. Good. Auto switchover check. THC neutral. Good. And let's configure for launch trim. Should be -1 and -0.5. Gimbal motors off. And let's take the batteries off, then auto. This will have them off, but they'll automatically switch on if need be, if we lose power during the pre-launch procedures. And we'll monitor our tank pressures now. FTI verification. Power both balls up now. Source, CMC, and IMU. Now the RSI, for whatever reason, on the ground is struggling to hold, but we can walk through those procedures anyways. EMS roll on, GDC line push it, move the cursor off, right click, and then release the left click. And that's how you can hold. And now we will yaw through 45 degrees. We can see that it is, for whatever reason, not holding. Or not doing the yawing properly. We can test it on roll, but Yeah, we can see it is just plainly and simply not working. For whatever reason, but that's okay. We'll bring it back to 0. Release. EMS roll off. And let's align GDC now. At set GDC. We can correct the roll here now. IMU and GDC are aligned. Take that back. And let's get our delta V set for the liftoff. We don't use the EMS. I forget what it's for. It's probably for COI insertion, contingency orbit insertion with the SPS. But I've never had to use it, as I've never requested an abort during the launch, so it never prompted me to use it, but yeah. Oh yeah, one thing I forgot to mention, I think I did before, left click does big values, right click does small values, and that's for all the things like this. Right click will move by 0.1, but left click will move by 0.5. Yeah, things like that. And switch to delta V. At the T-minus 55-minute mark, we're going to switch over for caution warning normal or acknowledge to boost, sorry. And uplink telemetry command will now be set to the normal. At 44 minutes, the pad abort will be enabled. EDS power on, gearbox, latch, unlatch actuator, man module RCS logic on, close the circuit breakers, logic, verify relay set, and pyro arms. Pad abort is enabled, and the white room is clear to retract now. There we go, white room is retract. At 28 minutes, we will take off our fans for the cryo system. And we'll pop her down to 25 minutes. For the service module RCS activation, open the helium isolation valves for both systems, 1 and 2, or both tanks rather, 1 and 2. Verify helium pressure. Close the secondary fuel valves. Open the primary fuel valves. Good. Good. And good. Now we'll queue up the launch checklist. So, while we've got time, there are some aborts modes. We can bring those up. Left clicking, yep. Right here, we'll bring up the power loss during the launch. Here's aborts 3 and 4. We should have boost aborts. Here we go. So abort mode 1 will be the counterclockwise neutral, and that's going to separate the service module. 14 seconds later, the tower, apex, and drogues are going to go, and then the mains. ELS logic needs to be set to auto for that time, and armed. And that's going to be alpha. And the launch vehicle is going to start dumping its propellant. Once set to RCS commands, it's going to move to here. Or not the launch vehicle, the command module, sorry. On mode Bravo, another counterclockwise, the service module is going to SEP. Launch escape tower, SEP, the canards. At 11 seconds, 14 seconds, arm the ELS. Cabin pressure is going to increase. Tower, apex, drogues, mains, pretty much the same. The only difference is that everything will have to be manually done. The 2 engine out as well. So when we abort with alpha, the command module will automatically dump its propellant. The launch vehicle will go into shut off 2 engines, will trigger an abort, or the rates will trigger an abort. But the propellant dump will be auto. On 1 Bravo, the propellant dump will be set with this switch is here. Still, 2 engines out on that first stage, or any sort of tilting or spinning of any kind that's not normal will automatically abort. On 1 Charlie, it's going to be, we need to abort if we notice those things. If 2 engines are out, we ask mission control. If the launch vehicle rates, we ask mission control unless they're violent. It's all going to be manual from then, pretty much. So it's going to be mission control's call at that point. And then we're going to enter mode 2. Mode 2 is going to be the tower is gone, right? The tower is gone, and if we counterclockwise, we're going to do a launch vehicle SEP. So the service module is going to detach from the command module. We'll separate from the service module, and we'll entry. When we go to contingency orbit insertion, then we can talk about burning that engine to insert into orbit. But until then, we just do an entry. So that's pretty much it. And then, of course, we do have some abort procedures for here, which are going to be our EPS and ECS aborts. You know, loss of power, loss of propulsion, loss of cryogenics. You know, how do we abort for there? And that is about it. Okay, yeah, that's all our abort modes. That's everything required for the launch. So let's align GDC to IMU again. You can already see alignment is very good. And then let's set up our auto RCS. Up, down, down, up. Oops, sorry. Up, down, down. Down, up, down, up, down. Down, up, down, down, up. These just tie to the different main buses. T-minus 15 minutes. We're going to verify battery C. Our isolated battery's got 35 to 37.5 volts. And we're good there. Take her back to main A. Get everything set to rate 1. These are the less sensitive setting for the launch. Otherwise, we don't use rate 1. Rate 1 is just for the launch. 5 by. Get direct on. Translation on, just in case of an abort. We're going to do a comms check. It is not simulated. We would take S-band and pad comms off for the middle panel, do a comms check, put them back on. It's not simulated though, so EDS power on, EDS auto, RCS command off, TVC servos on. Bring her down to 10 minutes. We need to latch to fuel cells for launch so that the vibrating doesn't cause a fuel cell bus trip. Secondary coolant pump is already off, so we can chill past 8 minutes 30 seconds all the way down to 4 minutes. Coming up on 4 minutes, we get the launch vehicle engine lights, signifying that the engines are off. We verify program 2. And we're going to enter verb 75, but do not enter. Verb 75 will queue up the launch program in case it doesn't automatically run. Tape will go forward. That's supposed to start at 3 minutes. My bad. Rewind the tape a little bit. There we go. And 3 minutes, tape will go forward. 2 minutes, 15 seconds, we're going to bypass the glycol to radiators. So we'll pretty much be relying on natural circulation within the spacecraft itself for the launch. 1 minute, 15 seconds, we're going to go on full internal power with the batteries as well. At 1 minute and 15 seconds, at 15 minutes, we were on full power with the fuel cells. Now we're on full power with the batteries as well. Just in case we do that CAPSEP, then we'll still have power. At 1 minute, all pad comms should be off. And at 45 seconds, we can take a GDC line, verify no motion, and release. And now, we are go for launch.
And Apollo 7, stand by for the 10-second count. 10, 9, 8,
Ignition
7,
sequence.
6, 5, 4. Ignition.
Launch vehicle engine lights out. Liftoff light. Clock start. Program 11. And that's all you need to verify. Clear the tower. We're going to verify roll program now. Roll and pitch program. You can see the rocket is rolling very slightly. Roll's complete. Should be stabilized now. Yep, we're stabilizer. One Bravo. Propellant dump to RCS command. Cabin pressure should start decreasing as our altitude climbs, and it will decrease down to about 5 psi, 5.5, 5, roughly somewhere in there. And we're at max Q. Waiting for the call out on 1 Charlie. You can see this thing is absolutely a behemoth with 8 engines. I do really, really like the look of the S1B.
Mark, Mode 1 Charlie.
Mode 1 Charlie. EDS manual. You can see no auto abort now. Laplace
Apollo 7,
PC.
you are go for staging.
And we are go for staging. Ready for center engines cutoff. Engines 5, 6, 7, and 8 lights should be coming on in about 9, 8, 7, 6, 5, 4.
Engines out. Come on board,
Board out. Sorry. Full staging should be happening very shortly. Staging. Ullage motors and ignition. Verify this one light here is out. Good. Liftoff light is out. Good. Key in verb 82. Enter. Noun 62. Enter. Activate our glycol system. Steam pressure to auto. H2O flow to auto. Jettison the tower.
3 minutes. Looking good, 7.
Mode 2. See, everything kind of happens very quickly for the launch.
Trajectory and guidance are go, Apollo 7. At 4 minutes, you're looking real fine here, 7. 5 minutes, Apollo 7. You're looking real good. You're right on.
Alright, we're about to be S4B to CUI.
Coming up on 6 minutes. You're looking real fine, Apollo 7.
Alright, S4B to CUI capability. Let's get gimbal position indicators going. Start our gimbal motors. Verify positions. Good. Go back to tank pressure. And let's wait for mode 4.
Coming up on 7 minutes. You're right on the old button. Apollo 7, guidance is go, and we see your step press and PU shift.
Good. PU shift. You're looking real good, Apollo 7. Alright, standing by for mode 4 capability. Mark, mode 4 capability.
Apollo 7 Houston, your trajectory and CMC are go. We have a predicted SECO of 10 plus 20. 10
Roger,
plus 20.
SECO at 10 plus
Mark,
20.
mode 4. Mode 4.
Mode 4 happened ages ago, sir. cut off. And we're in orbit. Look at that. Alright. Get this. Alright, get these papers out of here. I don't need them anymore. Where's a damn click point for this?
Apollo 7, we have you go for orbit. Go for orbit.
Ah! Where's the goddamn click point? Come on. Ah, whatever. Okay. So, read our velocity indicator, our
7,
H dot H pad,
has been saved.
key release, read a splash error, periapsis, and TFF, which is, I believe, time flight factor. Verb 37, enter 00, enter. Update state vector with that. Program 11 will update the state vector of the vehicle. Verb 66, enter. Alright, and now we're going to load our digital autopilot with verb 48. Verb 24 to modify both rows. 31102, enter. 01111, enter. Proceed, 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 and verb 46 is going to load that configuration. Or activate it, rather. Our rendezvous parameter, verb 83. Proceed. Looks good. Row 1 and row 2 should be equal to 0. Now, in terms of the insertion checks, I'm thinking I'm going to save the insertion checks for next time. We've covered a lot of stuff, and while I didn't go into any particular detail, it's a lot of switches and stuff to memorize.
Apollo 7 Houston, we have you in a 122 by 151 orbit.
Yeah, after a couple minutes of drag, yeah, that's about right. Okay, anyways, so yeah, I'll be signing off now. Thanks for joining, and I hope you guys get a better understanding of this vehicle as we go along.